All right, good afternoon or good morning, whatever the case might be. My name is Forrester Mid, Cloud Solutions Architect on the data team with Microsoft. So today's conversation really comes from questions clients ask around data lake and what are the enrichment transformation options that they have. Given the discussion, it is usually any one of these topics could be 30 minutes to an hour, so I'm going to do my very best to be brief as I go through the conversation and really walk you through a use case. And in this particular use case, what we're going to do is take a look at starting with zip files. So we're going to take a couple of zip files. We're going to use Azure Data Factory to take those zip files, land them into Data Lake. Within Data Lake, what we're going to do is we're going to use Synapse Analytics Spark to read the serverless database views that have been created and load that up into a data frame to enrich that data. Then what we're going to do is we're going to create a Spark database, turn off the cluster, and then create a view in serverless back to that Spark database, from which then I would use Power BI. So that conversation really covers a lot in terms of best practices. What are the use case? What are the scenarios? What's the cost matrix? I'll do my best to touch on some of these, but again, I want to focus on that flow of moving from zip files into data lake, into data lakes, into the Spark cluster. So like I said, any one of these conversations can be much longer, particularly when we get into the data lake discussion and whether we're going to be using bronze, silver, gold, or do we want to feed that directly into a SQL environment. So again, I want to emphasize this is a very specific use case that we're going to follow to compare and contrast spinning up compute for transformations versus provisioning compute running 24/7. And the use case will really drive that in terms of which one you might want to use. Right, so let's go over to, I'm going to start off with Data Factory. The reason why I'm using Data Factory is because I currently, at the time of this recording, the self-hosted runtime is not shareable to Synapse Analytics. So in it being I've already created my self-hosted runtime through Azure Data Factory, already had a lot of work done here. I wasn't going to redo all this over in Synapse Analytics, so I will switch over. The first thing we want to do is you do want a self-hosted runtime set up. And so this self-hosted runtime is connected to my laptop. This step in going through and creating the self-hosted runtime is well documented, so I'm going to refer you to the documentation to go through and get all that set up. All right, so let's begin with setting up a data set. And I'll just select new data set. We're going to be using file, and we're going to be using a file system. Again, the zip files. And let's pause here for just a moment. I've got a zip file located here on my laptop. Then I'm going to grab this zip file and load it over into the data lake. All right, so we'll go ahead and continue. It really doesn't matter. We'll talk more about this, of which format you'll use. But this just creates the shell of what we're wanting to do. In terms of the data set name, I'll just call this zip demo. And the link service is where we use that self-hosted runtime that should already be configured in your environment. We will select specifically a folder that we're after. That was that folder I was talking about just a moment ago on my C drive. I'm specifically after this demo zip folder and the files that are in there. You'll notice there's a zip file and a couple CSV files. The two CSV files are actually the files that are in the zip file, and each CSV file has a header. And I'll talk about later how we handle multiple headers when we start querying this data. Select OK. There's really not any schema to import, and we're not going to use the first row as a header. Again, we'll address that here in just a few minutes. Okay, so we'll say OK. All right, the first thing that we want to do is remember in this use case, we are going to deflate the zip files. So be sure you select the correct option that you're going to work with. I'm going to use zip deflate. On the compression level, I'm going to use optimal. There's two. I'll defer you to the documentation. Most likely, you'll just use optimal. I also want to create a parameter because I'm not after just one file. In the use case that this really was being driven from, the client had hundreds, thousands of different zip files. So what we want to be able to do is iterate through that folder, grabbing all those zip files and sending them over to Data Lake is what we're after. So the first thing I want to do is I'm going to create a parameter, and the default value is going to be star.zip. Obviously this could be a CSV file, so this is applicable to a variety of different use case scenarios. Okay. Now what I also want to do here is, in it being now then that I've created a parameter, I'm going to use that parameter so that when I iterate through the folder, picking up those zip files, I get the content that I'm after. So I'm just going to select that parameter, demo zip. Okay. So that creates our initial step here for getting the data configured. Not any other options down here that I need to work with. So now what we'll do is we're going to create a pipeline and use that data set. Now in the pipeline, what we're going to use is the metadata lookup. So it's in the metadata lookup that then what we'll do is we'll also set, and we'll go ahead, let's give this a name, and we'll just call this demo metadata. What we'll do here is on the data set, all right, we're after that, we can just do a filter here and just do zip demo. That's going to be our source data set. Okay, so we've already got the information configured because we selected the data set that we're working with. But remember, we're going to be iterating through this. So what we want to do is add in an argument for the child items, right? Because we're going to be looping through sequentially through all of these files. So let's give this a test and see what we get. So we'll do a debug. Okay, and then what we'll do is we'll take a look at the output. Now you'll notice here I've picked up that demo zip file. Well, let's do another test here. And let's go back here and grab another zip file just to double check and make sure that we're going to get two zip files in here is what we're after when we do our test. So let's go back. We'll do another debug and run this, and this time what we should get is we should get two zip files. Now there's another piece of information here that while we're here, it's very important to call this out. Try not to be too chatty. Try to keep this discussion as short as I can for uploading up into YouTube. But here, when we do our get, you'll notice now that I've got the two files. So this is working correctly. What I wanted to call out is if you scroll down just a little bit, you'll notice this duration or the unit hours. Working, remember, Azure Data Factory / Synapse pipelines, they're identical. The charges are based on throughput. Now you could have thousands of activity runs and pipeline runs. It's going to have very little impact on your cost. If you go into the Azure pricing calculator, you'll see that. It'll be the data integration unit hours that is what's really driving the cost, and that's the compute. So that's really the main charge associated. So when you work with Data Factory, keep that in mind. Right, so next what we want to do is we're going to add in a for each. Now what the for each is going to do is it's going to allow us to iterate through passing the information from the metadata into the for each is what we're after. So by selecting the for each, we'll use the settings, we'll do sequential, and for the dynamic content, we'll just select the demo data dot child items. Next, what we want to do is there's a couple of there's activities in here that we want, and this is going to be a fairly simple activity. We're just going to use a simple copy command and drag in the copy command. For the copy command, what we want to do is on the source, we already know that we're after the zip demo data set. In it being that we do not want, this, we're not just grabbing this .zip. What we're going to be doing is feeding in to it a name from the iterations that we're doing from the for each. So if we select the for each and we do .name, now then what we're able to do is iterate through grabbing that parameter that's passed over, and that gives us the name of the file. You'll also notice here there's a couple of other settings that we're going to scroll down. We're going to leave the recursively turned on, but notice the preserve zip file name as folder. We're going to leave that checked. And the reason for that is you can imagine if all these files, these zip files are coming in, we're going to use the name of the zip file as a folder. So don't be thrown off when you see .zip. It's not just the zip file, it's actually a folder .zip named with .zip, and then the files underneath it are available. Now on the sync, what I did, I'm going to jump back over to our connections here, and I already created, our data set. On our data sets, I've already created a zip sync, and what I did was I'm just feeding this into a folder in my data lake, Gen 2, and I'm sending that the zip files into a folder called compressed. Okay, so let's go back over to our pipeline, and we'll go back into our activities. And on our sync, what I'll do is I'm just going to use, what was that, zip sync. Okay, and then that's all been configured for me. I don't need any changes here because those are going to be files. I do want to change this. These are going to end up being CSV files. And that was that reference earlier. It really doesn't matter so much what you take. All these will end up being pretty much the same. All right, so I've got my copy command. I've got my sync set up. If we go back to the pipeline, what we'll do is let's switch. I'm going to switch over to Synapse. We'll go into this compressed folder. And I'm going to delete both of these files just so that you see, or folders rather. And what we'll do now then is we'll go ahead and run a debug on this. And what this is going to do now then, the metadata is going to read that folder. And for each zip file, it's going to send that zip file and the name over to my for each. And in the copy command, what it's going to do is it's going to deflate and then land or create a folder. And then it's going to land the files from that zip file over into my storage account. And if we go over to our storage account, probably already start to see some content starting to be built here. There's our miscellaneous files.zip, that's a folder. Notice the folder icon and the content type is folder. If I drill into that, you'll have the CSV files that are in that were in that zip file. Scroll back up, do another refresh here, and see if we can pick up the last file. There's our PS demo zip. This is actually the one that we're going to be working with. And if we drill into that, those two files have completed. And if we go back over here and do an update back into Azure Data Factory, you'll see that this has all been completed. And again, I just want to remind you that this information that's associated in here is very important for your cost matrix. Okay, so all this has been completed. From here, we'll spend the rest of our time over in Azure Synapse. So what have we accomplished so far? We've taken zip files, we've used Azure Data Factory, we've taken those zip files, we've iterated through a folder and copied each one over into Azure Data Lake and uncompressed them into a folder, which was actually the name of the zip file. From here, what we want to do is start in a conversation, and we're going to be working with an Azure Synapse serverless, and we're going to have a conversation about Synapse serverless, and then what we'll do is we'll move into a conversation using Azure Synapse Spark. All right, so to begin with, you'll notice I've got these two files. If I select these two files and I right-click, you'll notice now then I can do a select top 100 rows. Now, this conversation also touches upon, if you're working with Dynamics, if you've got Dataverse or F&O, the current recommendation for Microsoft is to do an export to Data Lake. So this conversation, you'll see, will be relevant, particularly as we get into working with those views that have been created. Remember, the virtual database, virtual views, we'll touch on this again in just a moment, is not moving any data. The data stays in the data lake. It's just being queried through the serverless built in, and that's what we're looking at right here. So if I were to go ahead and run this, you'll see probably right off the bat, we've got header names, and if we scroll down, and if I got enough data in here, you'll see, if I change this off, you'll see, I just do a select star, and run this. As we scroll down here on the 2015, notice then that we'll get into, when we switch over from 2015, get into 2016, you'll see that we have another header. And so how do we handle the additional header? All right, well, it's not going to behave. I don't go waste our time looking for the additional header, but there's two headers in there. So what we're going to do is I'm going to switch over to our views that I've already created. Let's just speed things up here a little bit. If I go into my compressed view, I've already got some views. So this is the same view that we just ran just a moment ago. So what we want to do is talk about the serverless built-in. The serverless built-in was not intended to be large data manipulation. So when that data lands there into the data lake and you start querying that data through the built-in, remember there are some limitations here. First of all, it is a shared compute resource using the built-in or the serverless approach. There's no compute allocated directly to you. So if you ran a query and you ran it again in 5 or 10 seconds, it might run a lot faster than the first time. But that's only because it was cached. The minute somebody else runs another query, the memory or that cache data is removed. So you may run it again, and now then it takes the original time. That's because there's no query execution plan being maintained for the serverless built-in. So just keep that in mind. Also remember that with the serverless, when you're executing through, it's actually massive parallel processing in the background. And so what you're actually doing is sending a query to the control node. The control node takes that query, breaks it down into distributed SQL or D-SQL, and then sends that to the nodes, up to 60 nodes. So every time you send in a query, it goes through an algorithm to determine the most optimal number of nodes to execute and run that query. So hence, as you start to run this, you may not find it to be very performant. So the conversation that we're going to start walking into now is that discussion of where I'm planning to use Synapse Spark to take the serverless views that I've created, load those up into a data frame, and then the data frames, I can join the data frames, manipulate the data frames, do whatever I want. But before I do that, I'm just going to talk about some light manipulation. So the first example here, you'll notice that I've changed from the name of the file, and let's say there's multiple files, so I'm just going to use the wildcard.csv, and I've also only selected certain fields that I'm after. Very common that files that land into Data Lake, you may or may not want all the fields that are in that file. So again, you can leave them in the Data Lake, query them as needed. So in this example, I'll go ahead, we'll run this query, and what we'll see then is now then I have the field names and I also have the metadata type. And the way that I did that was I was able to add in the header row underscore row equal true, which gives me one header row for these two files that were joined together. So I consider this light manipulation. Other options would have been to extract that data over into a SQL environment. That's a provisioned resource. Now then you're paying for the compute. In this example, what we'll do is we're going to go through and create some data frames using Spark. All right, so how do I get started here with this? If I'm working with, let's go to the master. So again, we're going to be creating essentially a virtual database. So switching over to our database tab, if we go into the workspace, you'll notice then that I have these various different databases, but important to note, see the icon? This is referring to a dedicated SQL pool, which is a provisioned resource, versus a serverless database. And what I want to do is I want to create essentially a virtual database, and that's what I'm going to do here. We'll create a virtual database called compressed new. And now then if we do a refresh on our database, we have this compressed new database, but there's nothing in it. I'm going to leave, and probably in my examples I may reference this, but I just don't want to step on anything later in the demo, so I'm just doing this for descriptive purposes. So now what I want to do is I want to create a view. So what we'll do is we'll use that exact same query that we ran, but you'll notice I used just simple syntax, create view. And that's going to be, now that I've created that database, we'll grab that database, and now then we'll create that view in that particular database. Okay, so now then on the compressed new database, I do a refresh, we have our view, and there you go. Now that I have that view already created for me, and I have the metadata that I defined over here when I created that database. Okay. All right, so let's take a look here at what we want to do next. So now that I've got this view, the question can come into play as to I want to do heavier manipulation of this data, right? And I've already done some light manipulation, whether it came from Dataverse or it came from zip files, doesn't really matter. But the use case is now, we'll switch back to our diagram. So now that I've done some light manipulation in here using our serverless views, and remember on serverless views, the charge is per terabyte of data that's been read. And so it's roughly $5 per terabyte of data. So you can do some really light manipulation. A lot of clients will use that endpoint in Power BI, Excel, reporting services, whatever it might be, Tableau, and they'll use that endpoint and they can query directly into that view that's already been created for them. So in some use cases, that might be great. But if I'm going to do heavier manipulation of data, I'm going to be working with larger data sets, you're either going to need to send it to a SQL environment or you're going to need a Spark cluster. All right, we're going to use a Spark cluster. So first steps is a couple of setup options. When we go to our cluster, let's switch down here and go to our cluster. One of the things that we're going to need in our workspace, in order to connect to the serverless with Synapse Spark, I need to download these packages that you see here. The link that you want to go to, Samara actually already wrote this up. She provided a really great description here. She's no longer with Microsoft, very talented lady that she provided this information. There's probably other approaches that you can use, but this is the approach that I'm going to take, and it worked just fine for me. So after you download these packages, you'll need to go and add those packages to your Spark pool. So now I'm going to use this cluster. It's a fairly small cluster. And if I go to my packages, I import those packages into my cluster. That allows me then to use the serverless for this example that I'm working with. All right. So if I go back over to my Python, I've already got this running, and of course I'll replace my secrets and all this. But if I run this, this just loads up my properties and it creates my initial data frame referred to as data. So from here we're going to step through trying to be brief as I can, but adding a little additional commentary with what we're doing. Now, the approach that I'm taking is I used this approach here. It's a great discussion, and it steps you through working with, if you're working with Anaconda or some other local whatever, it would work just fine. But in it being I'm using Synapse, PySpark, there's some changes that I have to make, and that's what we're going to go through here. So this will be applicable use case. What we're going to do is take this data frame, we're going to enrich it even further, and ultimately create a statistical model off this. We're going to use plotting, and then what we'll do is we'll use the Spark database to write it back to, turn off the cluster, and then we'll use Power BI to query it to give you an idea of the process that you'd go through. So first step, let's get out of the way. Some of the libraries that we want to import, probably importing more than I needed. I just noticed here I won't even be using this. But anyway, so those are in there. Python turns out to be, actually it's a lot of fun. It's easy to use. I'll show you an example here in just a moment where I could just use SQL against the data frame. But in this example, what I'm doing is I'm creating a data frame, dfrep, and I'm only going to pull in these 3 fields. And you'll notice there's several other fields that I could work with. So again, if I were working with a very large data set, this might be an approach to take. It just depends on your use case. I've filtered it out based on the sales rep that I'm after. I've changed and modified the date format, and then I've also renamed some columns so that instead of using some sales amount, I'm using rename it sales. You'll also notice then on the dates that we're looking at, the date, even though it's month by month, you'll notice the days are all the same. So that's usually probably the first place that I always got tripped up, is that if you don't have the same date here, the statistical algorithm gets confused in the date range that you're trying to project. Okay, so watch that. I changed all these dates back to the first day of the month so that I had an equal time span for the projection. Now here's what we can do. If you're not comfortable with Python, I really recommend it. It's really easy to use. It's easy to pick up, a lot of great documentation. But what I'm going to do is I'm going to create a temp view called sales plot. And once I do this, I'm able to just use SQL syntax to now query the data frame. So instead of, as we go forward and working with some of the syntax around Python, you may choose, in most cases, maybe move further along with just using the SQL against it. And so now then, I'll just use plain SQL using sales plot as the table name that I created up here. Once I've done that, I've got my fields, and then I could go ahead and chart as well, and we'll just change this over to a line chart. And now then, there you go. So now I've plotted that 2 years of actual data. So let's go on and move into a little bit more in terms of some of the enrichment that we're going to do. And again, we're going to do a time series forecast off this 2 years of data. So the first thing I need to do is I need to create this over to a pandas data frame. Turns out that this is an approach that seemed to work for me. And by changing it over to a pandas data frame from a Spark data frame, it allows me to now have this index. And what I want to do is I want to change this index to invoice date, so when I use matplot, that it lines up and gives it the appropriate information. So that's what I'm doing here. I'm just setting that data frame that I just created, dfrep underscore PD for pandas. And I'm setting the index on the invoice date. And I'm using in place true to leave the existing. I'm just sort of updating that data frame. And now when I plot this, we'll use matplot. And now that I've plotted out those 2 years. So let's scroll down now and get into some of the time series forecasting that we want to work with. So what we need to do is when we start doing statistical models, and this is going to be one of those areas where I'm going to touch on it, but this is sort of an onion. You'll need to peel back. There's a whole lot more involved in this discussion than I can squeeze into the time frame that we're going to be working with today. But what I'm going to do is I'm going to take 18 months, or actually I'm going to take the 24 months. I'm going to take the first 18 months, and I'm just going to call it train. And I'm going to take the last 6 months, and I'm going to call it test. And what that does for me is it gives me a visual in my map plot. When I plot this out, it gives me now a visual that you'll see here, that it shows essentially the actuals that goes all the way, but I took the last 6 months and I put them in red. The reason for that is because when I do a projection or prediction, I want to overlay that prediction to see how accurate my model is. And then what I'll do is go ahead and do my forecast, and I'm going to marry up this data frame with the prediction data frame so that I have one complete data frame for the entire projection. So here what we'll do is we'll change this time period to month. And this is the gentleman on my team, Cameron, helped me with this. I think he's, with all due, I think he may be visiting us from another planet. He is beyond, he's just incredible in terms of his skill set. So he helped me with a couple of these areas, particularly here and here. And so what I'm doing is I'm setting for the pandas data frame, I'm changing this data type, sales, to a float. And that allows all goodness as we go forward. So here what we'll do is let's play around with this just a little bit. And let's do 2, say 1, 2. And what I'm doing is I'm going to import the ARIMA data model, a statistical model, and I'm going to add in some of the parameters here. And what I did was I'm forecasting 12 months, and the rest of this is just plotting this out. So let's take a look and see what we get here. Okay, so doesn't work very well, doesn't even come close. So let's change these parameters, and let's change this one to 2, and let's run this again and see what we get. So what you're seeing is the ability to start manipulating the statistical modeling, overlaying the actuals, and overlaying the projection over top of the actuals. And what I'll finally do is change this to, I think it's 4 and 4, and that gets us just a little bit closer to what we're after in terms of our model. Again, it's going to be outside the scope of this discussion to dive deep in statistical modeling, but again, just for the sake of the conversation, it gives you a feel for the type of manipulation that you might want to do with this data. So let's say that after all of our manipulation, although this one doesn't lay over entirely because you've got anomalies in here that you need to deal with, but let's say this projection, this last 5 months of projection, is really what I'm after, and I'm ready to go ahead and proceed forward. So let's go ahead and start with getting a look at what we have here. So I'm printing out the predicted data frame, and you'll notice that I have my column over here which is indexed, and I need really what I need is for this date, invoice date, to be a column, and then what I'll do is only get the predictions, and I'm going to rename the predictions to sales. And then what I'll also do is change the formatting to be compatible for both the data frames that I'm going to union together. So that's what I'm going to do here. So starting off, I'm going to create a new Spark data frame. I'm going to call it, it's still a pandas data frame, but I'm going to copy it. And then what I'm going to do is I only want the values after 2012. So that gives me only the predicted values for this particular data frame. Next, what I want to do is I want to change the index. So I'm going to reset the index to give me my invoice date. And now what I'm going to, as a column, as a field. And now what I'm going to do is I'm going to rename index to invoice date to give me my final data frame that I'm after for the formatting. So this gives me the format that I'm after. But now what I need to do is I need to change the invoice date to a string. Why? Because when I convert from a Pandas data frame back to a PySpark data frame, I'm going to start encountering some data type mismatches. So it's easier just to set it as a string, and then in the PySpark data frame, format it as I need to. So that's what I'm doing here. We'll go ahead and make that change. And the last thing what we'll do is we'll come down, and finally we're going to take the predicted data frame and we're going to convert that to a Spark data frame. And notice I'm using schema equal none. If I wanted to, I could have done the schema names, but the way this turned out is I didn't need to do this. And I was able to just continue on here. So when I run this, I now convert that Pandas data frame back over to a PySpark data frame, and that completes the piece with regards to getting the predicted values over into a PySpark data frame. But let's not stop there. Remember, we need to get the data types. Again, some additional manipulation. I'm going to only pull out the invoice date and the predictions. And then what I'm going to do is I'm going to format, remember it was string, so now I'm going to format it to a date field. And then I'm going to do some formatting with the column on the sales amount. And last, I'm going to rename the predictions column to the sales column. So that's what I'm doing here. This is preparing the projected data frame to get it aligned to the data types so that I can union the actuals that I was working with, the data frame actuals that I was working with, to get those to union together. Otherwise, you'll end up with some data type mismatches. So last, what we'll do is we will round these columns off. Now these are the actuals. Okay, so dfrep, remember that was the data frame that we started working with and did the manipulations. So what I want to do here is I want to make sure my data types are the same, and I'm going to change the data type sales to a rounded as a double type. Okay, so that's what we're doing there. So now that I have, and of course, if you ran this and you tried to do a union on them and they didn't union, you'd get the Halloween messages to work through. So now what I'm going to do is I'm going to create a final data frame, and I'm going to take the predictions data frame, those are those 5 months that I was working with, and I'm going to union that with the actuals. And that gives me my final data frame that I wanted to work with. So we're just about finished here. There's a couple more things that we want to do. Let's go back to our PowerPoint. So what we did was we took those the zip files that we copied into our storage. We used the Synapse serverless to do some light manipulation of that data, and I want to underscore light. It's relative, depending on, don't want to discourage you, but I'm just telling you now, if you're going to start working with, multiple joins, inner joins, outer joins, subqueries, I'm telling you now, serverless Synapse is not going to work for you. You need to use a different compute. You could feed that over to a SQL environment and have that provisioned, or you could use a compute like Spark that when you finished with it, you can turn it off, right? And now then you can use that data set. This data set could be fed back to storage. I'm going to feed it over to a Spark database, or you could have fed it directly into a SQL environment. The use case is depending on your use case, the target of the enriched data will be dependent upon that. A lot of clients, if we digress just a moment, will use this bronze, silver, gold with enrichment in each phase, both enrichment and security level, to where gold is the curated or the available to be consumed by most clients. Okay, so let's go back over to our data frame, and we've completed this. So what I want to do is we're going to switch to, I think we have let's do this. Let's drop this Spark. We'll just run this guy. And that should just drop our Spark final database without having to do all that. Could have done it the other way, but this gets rid of it just as easy. So if we refresh, our Spark final data frame is gone. And then what we're going to do is we're going to create our Spark final database. And we're going to use the final data frame that we just created. And we're going to put that in the predictions table. So that's what we're after here. So if I run this, that is going to create a new Spark database. Likewise, I could have sent this directly into a storage account, and then I could have created a view on it. But I just wanted to push you a little bit here and take a look at the Lake database, or in this case, the Spark database, and show you a way that this can be leveraged. Remember now then, when we're finished here, when I have this Spark data phrase, so there's our Spark database that we've created, and there's our table prediction. And then from here, we could run it. So what we want to do now is leverage the serverless endpoint here. And what we'll do is we're going to turn off this cluster just so that you can see this in action. So we're going to turn off the compute that we use to create this data. So ideally, the way this would work is you may have enrichment. You run this, you execute it. You could kick it off through Synapse pipelines and kick off this whole notebook versus clicking through each one of these cells. It was really more of a tutorial. But you could kick this off, feed it over into update the Spark database, and then your serverless view is always pointed at the Spark database so that then when we use Power BI, it's always being updated. Okay, so that's what we'll do now. So let's go to our query, and we will, let's see if we've got, I think I've got that already in there. Yep, sure do. So what I want to do is I'm going to create in my compressed new, right? Remember we used the views. These are tables. This was just a virtual database, and I've created virtual views. What I want to do is create a view off that Spark database. Why am I doing that? Well, because I don't have to have the Spark cluster running, and I can use the serverless now to query that file. So now then I'll run this, and that is going to create a new view for me. So if I go into my views and do a refresh, I have my prediction sitting here that I've named DF prediction. Okay, that's the name of the view. So what we want to do now is use Power BI. Now Power BI will use the serverless endpoint, but it will not read the Lake database. So what we'll do is we'll go into our views, and we'll go in, our notepad, we'll go into Power BI and the data sets. And we're going to use the new data set that we just created, compressed new. Now I have had some trouble with this, so if I get an error, that is just the way it goes. So I'm going to do a save as and drop this into my download folder. It looks like I've already done this. I'll replace it. And now then I'm going to open up that file. It seemed like if I opened without saving it, I was getting an error, and I think it was the credentials that weren't being passed or something like that. I'm not sure. So this worked. We'll see if this gets us where we need to be. So this should give me a connection to the serverless. And in the serverless, if we expand this out, you'll find that we have that prediction that we just created from the Spark cluster. And this is then the view in the serverless that's pointed to the Spark database. We'll go ahead and load this up. And you could import it. Now remember, importing is going to require a refresh, or I could use a direct query. I ordinarily do not recommend or use direct query, but since a small little data set, in some use cases, direct query should be just fine. If you are going to use direct query, I would encourage you to look at the Power BI data mart, which is now, you should be able to find a lot more information about the optimization of working with direct query there. Highly recommend that read. All right, so we've finished our import from that connection, and we're just going to do something simple here just to show and wrap this discussion up. So I have my view. We're not going to get into a whole lot of Power BI work here. So we'll do Control C, and I'll just copy this over. And move this guy over here, and I'm going to make this, so change that over to just a table, and you get the idea, all right? So let's say now then, and again, encourage you to work with Power BI. It's out of scope here to get into all the nuances in working with Power BI, but we are going to change this to a public data set, and we're going to publish. Now, it turns out that Power BI, if you link the workspace that you have within Power BI to Synapse Analytics, you'll be able to publish to that workspace. In this case, I've linked my Synapse workspace. So when I select that, that'll publish this up into that Synapse workspace, which is linked over into the Power BI workspace, which the workspace, Power BI workspace, is linked to the Synapse workspace. I have to go back and listen to the recording. Hopefully I got that straight. Right, so now then, if we do a close and refresh, you'll notice now then I have this data set. It might error out, and it might not. We'll see. And if it does, I'll show you how to go fix that. All right, so here we go. We have our data set. We have the view. We'll go ahead and recreate. Actually, I was thinking it would have saved that report for me, but I guess it's going to make me recreate this. That's fine. And now then I have the contents that I'm able to view that I went through that enrichment process, and I'm now then displaying them here directly within Power BI. In some cases, when you publish this up, you may have to go to the data connection. If I go back to the Power BI workspace and I go into this data set and I go into settings, you may have to come in here and update the connection information. So just be aware of that. It's no worries. Fairly easy to do. Share online settings, and it'll be right here on your data source credentials. If you don't have that set up, that'll be lit up with a Halloween yellow, and you'll just add the credentials and add in your credentials so that you should be able to see it. So if we go back here, there's the view that we've created off of that data set. Okay, so let's do a quick recap here. It's getting a little bit longer than tried to keep this as thin as I could. The objective, just in summary, was to take a couple of zip files, and within those zip files, that in this case they were on premise, I used Azure Data Factory to iterate through that folder and load those into Data Lake and deflate the zip files into folders by the zip file name and the files underneath that folder. Generally speaking, this is a broader conversation around bronze, silver, gold, so you can imagine they dropped into just the bronze, or raw is another reference here on the bronze. Now, once in Data Lake, the common question is, well, now I need to do more transformations. You have options. You could have done the transformations using Azure Data Factory / data flows. You could have fed that data into a provisioned SQL database, into a staging database, then hydrated a production schema, or you could have used Spark, and there's probably other options you could pursue. The reason why I chose Spark was because it seems to be a very common conversation. It comes up all the time, and instead of having a provisioned database, scaling up and scaling down the compute on a provisioned database, that is in production. People are doing their reporting and analytics off of it. You might want to use Spark, if it's a good use case fit, to use Spark to spin up the compute, do your enrichments. I'm still querying using the serverless, and do that enrichment, feed that back into either a Spark database, back into the files using serverless, then using the endpoint for the serverless with Power BI while still in Synapse or outside of Synapse, and then being able to publish to the Power BI workspace. And if the Power BI workspace is linked in with the Synapse, you can view all those reports directly within the Synapse workspace as well. All right, so I told you this was going to be a little long. It is a long conversation. Any one of these topic areas you could spend 30 minutes, an hour, or more. So I'd encourage you to reach out to your solution specialist /CSA and set up a discussion if you want to learn more about this. So again, thank you for your time and appreciate it very much. Thank you.